guys, welcome to Tacsfon Lautech Academy, and most especially welcome to physics tutorial class. I'd like to take you through the topic simple AC circuits, and that is simple alternating current circuit. So quickly, we'd like to define what simple AC circuit is. So simple AC circuit is a circuit through which alternating current flows through, but it's possible that this is the first time you are hearing the word alternating current, contrary to probably the direct current that you have been used to. Direct current is such a current that flows just in a single direction, such that when you have your current plotted against time, the current flows just in a single direction. This is for direct current. But now when we are considering alternating current is when you have your current plotted against your time, but you are having a curve that is sinusoidal, just in this form. So we can say that an alternating current is a current that flows sinusoidally, or it varies periodically. Just as you can see, it varies with time. So that's that for alternating current. And for you to have a circuit diagram, the circuit diagram is such that probably when you have your resistor at this point, it is connected to a current source, just as you have it here, contrary to what you have in your DC, whereby you have a cell battery. This is what you have for a direct current. But when you are considering an AC current, that's when you have your AC source, just as you can see there. So let's quickly consider what we mean by peak values of current and voltage. So for you to have the peak value of a current or a voltage, what we are referring to is just the maximum current that you can attain in your AC circuit, which is this point, and this is what we refer to our peak value of our current, our peak current. So if we want to consider our peak voltage, what we just need to alter here is just by changing our voltage. We are by plotting our graph, that's voltage against time. So this way we have our peak voltage, that is the maximum voltage, just as we have it in the alternating form. And quickly we like to discuss what we meant by root mean square values of our current and our voltage. So the root mean square values of our current and our voltage is just essentially the effective value of our current, and also we can have it as the equivalent to the steady direct current that converts electrical energy to other forms of energy at the same average rate as the alternating current in a given resistance. So quickly, we like to make an evaluation of what our root mean square value of our current is by comparing a DC circuit with an AC circuit. That's the average power of a DC circuit. So that way we have, normally we know that our power is equals to current times voltage. But now we want to consider the average power, which will be our power is equals to, this is our average power, which will be half of current times velocity. But we need to know that this our current in this at this point is our effective value. So this way we can consider it as our peak value. So this way we can consider it as having our average power to be and since you know that from your Ohm's law, V is equals to IR, but in this step you are relating your V equals to IR in respect with the maximum current such that you can have your this to be high efficiency square R is equals to half your peak value of current, then IR. Then this way you have high efficiency square R is equals to half I naught square R. Then what we want to do at this point is that we want to get our IRMS, which is our root mean square value of the current. So what we just need to do is make it the subject of formula IEFF squared. We know that the resistance at this point we cancel out. Then what we'll be left with is half the peak current, such that we can have our I effective value or IRMS by squaring both sides. That way we have IEFF is equals to, that will be square root of I naught square all over square root of 2. So that way we can have our effective value of our current to be I naught over root 2. And we know that definitely we can still simplify this further. So simplifying this further, we have our IEFF to be 0.0701 I naught. So this is the relationship between our peak value and our RMS, that is our, which is also known as effective value. So in the same manner, to get the relationship between our root mean square value of our voltage, what we just need to do is still to compare the average power, but now we'll be comparing it in terms of our voltage and our resistance. It will not be in terms of current and the voltage, just like this relationship. We know that there is a relationship between power, voltage and resistance, just as we have it here, power, current and voltage. So in this way, we know that our power also can also be equals to V square all over R. So this way, how did we establish this? It is still from this basic relationship, since we know that P is equals to I times V, and we know that our I is equals to V over R. So this way we should bring them together. We have V over R times R. That way we can say that, V over R times V. So we have V square all over R. So that's what we want to do this here by comparing our V square over R. But in this case, this will be the effective value. Then we are equating it to the peak value square all over R. Since we know that what we want to consider is the average power, so there will be a need for 1 over 2. And this way, what we will cancel out is still our resistance, so that we will be left with V, the effective voltage square, is equals to V naught square all over 2. Squaring both sides, what we are left with is V effective is equals to square root V naught over 2. That we will have our V naught over square root over 2, which still give us a similar answer, which is 0.071 V naught. So this is the relationship between the effective value of our voltage and the peak voltage. And don't forget that our effective voltage is still known as our VRMS. So let's quickly take these two examples. We have two questions before us. The first one states that the peak voltage of a 110 main supply is, so in the question we can see that what we are given is the effective value of the voltage, that's the VRMS. And we know that the relationship between the effective value or the VRMS and the peak voltage is the peak voltage all over square root over 2. Since what we are looking for in this case is the peak voltage, we make it the subject of the formula and then we cross multiply V effective times root 2. So that way, I said what we are given initially is our Vrms or our V effective, which is 110 voltage. So that way we have 110 voltage times root 2. Computing this, we have it to be approximately 156 voltage. So that's that. So that way our answer is B. So for us to consider the second example, we can see that this is with respect to current. So an alternating current which varies from 0 to a peak of 20 ampere has an effective value of, so in this case what we are expected to look for is an effective value of our current. Then they already give us that our what? Peak our peak current rather now is 20 ampere, and we know that the relationship is still I effective is equals to our peak current over square root of 2. So in this case, what we are looking for is our effective value. That way we have I effective is equals to 20 all over root 2. That is, since our peak current is 20 amperes, so we have our A effective to be equals to 20 all over. When you look for your square root of 2, you have 1.4 blah blah blah. That way you have, simplifying further, you have your answer to be 14.1 amperes approximately. So let's take this last example as we'll now proceed to the various forms of simple AC circuits in our next video. So we have before us a question which states that a 200-watt laptop is connected to a 240 volts AC line. We are asked to calculate the RMS current flowing from the outlet. From this question, I want you to note that this value that is being given to us is our root mean square voltage, and in that light they are asking us to look for our root mean square current. So we know that the relationship is just power is equals to root mean square current times root mean square voltage. Then also we are asked to look for the peak current, the peak voltage, and the maximum power delivered. So let's start from somewhere. Given that our Vrms is equals to 200 voltage, and we are asked to look for the root mean square current, we don't know that, but we know that power is equals to Irms times Vrms. So what we just need to do here is just to make Irms the subject of the formula, and we have P, our power is equals to Vrms. So that way we have our 200 all over 240. Simplifying this further, we have our answer to be 0.833 amperes. So that's that for the RMS current. For us to proceed to the peak current, since we have our IRMS current and we know that the relationship between our peak current and our IRMS is just our IRMS is equals to our peak current over square root of 2. So this way we need to make our peak current the subject of formula, then multiply our root mean square current times root 2. So that way we have 0.833 times root 2. Simplifying this further, our answer is 1.1785 ampere. You can do all to confirm that. So also let's quickly go to our peak voltage. So how do we get our peak voltage? Since we have our root mean square voltage, the relationship is root mean square voltage is equal to our peak voltage over root 2. So that way we have our peak voltage to be equals to our root mean square voltage times square root 2. Then our root mean square voltage is 240 volts, just as you have up there, then times root 2. Simplifying this further, we have our answer to be 339.4 voltage. And lastly, we are asked to look for the maximum power delivered. This should not be a problem, since you know that your maximum current is your peak current and your peak voltage is your maximum voltage. So for you to get your maximum power delivered, you just need to multiply both together. So that way we have our maximum power delivered to be our peak current times our peak voltage. From our computation so far, our peak current is 1.1785 amperes times our voltage is 339.4. So multiplying this together, we have our maximum power to be approximately 400 watts. So you will see that your maximum power is 400 watts, while the average power that you were given initially is 200 watts. So that way we can establish a relationship between our maximum power and our average power, which is our maximum power is twice our average power. So that's the end of this tutorial video. Then we'll proceed with our forms of simple AC circuits in the next section.